expect a question from metal carbonyl. You should know when it is about metal and a ligand in coordination compounds. Of course, the ligand will have a pair of electrons that can be donated. If it is donating, it forms a sigma coordinate bond. Where is this donation happening? You have some empty, can I say, the pi orbitals or p orbitals are empty. So because of that, there is a sigma bond that is formed. Now, because the carbonyl or CO is very unique, it also has anti-bonding molecular orbital. When you see the molecular orbital diagram of carbonyl, of CO, you will see there are anti-bonding molecular orbitals. So because there is an availability, when it feels overwhelmed, when it has actually carried out a lot of charge, it wants to just get released. It wants to ease off, just like how when you go with a gift on a birthday party, you get a return gift at times, don't you? If you go to a wedding, maybe you get a mithai ka dabba. That mithai ka dabba is out here. This is a return gift. And because of this return gift, do you understand? The electrons are entering the anti-bonding molecular orbital. They are entering the anti-bonding molecular orbitals. Because they're entering anti-bonding molecular orbitals, and we know that bond order is equal to number of electrons in bonding molecular orbitals that minus number of electrons in anti-bonding molecular orbitals divided by 2. Since the electrons are entering anti-bonding molecular orbital, bond order will decrease. Whose bond order will decrease? Of CO. Okay. Now, as a result of this synergic bonding, this back donation, this synergic bonding, which we are calling, the bond here is coming out to be a pi bond. That means there was one sigma bond and one pi bond. So metal carbonyl bond is becoming stronger. This bond is becoming stronger. But if we look at the CO, because the electrons has entered anti-bonding molecular orbital, this bond has become weaker. Do you understand the result of this back bonding? Bond order decreases. Whose? Of CO. So if bond order is decreasing, can I say the bond strength also decreases? Right? These are the areas from where the questions can come. The first kind of questions, wherever you see these synergic bonding. What is synergy? For example, here is a cow. Here is a cow. Okay? The cow has got a lot of lice. You understand lice? We call it Jew. Jew, zoo or Jew, I don't know, right? So it has got a lice. Now here is this bird, maybe a radio or antenna. So here is this bird who comes and sits on the cow and eats this lice. It is eating away this lice. So lice is a food for the bird. So it fills the bird up. It is acting like a food and it is helping maintain the hygiene of a cow. Cow, because have you seen a cow, by the way, itching? It will just itch in a very, very desperate way. If there is some tree or a pole, you would see that how annoyed a cow can get because of these lices. Thanks to this word, the synergic bonding here, that yes, this cow is getting care of the hygiene and the bird also is getting the food. This is what we call as synergic bonding. Same is happening here. This CO had this lone pair that can be donated. As a result, the molecular orbitals of the anti-bonding molecular orbitals, which are empty, gets electrons from the metal, and because of this, there is a synergic bonding which is making both of them stable, right? Now, what kind of questions can there be? You can be asked questions related to metal and carbon bond. So if you understand metal and carbon bond, there is a pi bond character coming up, and carbon and oxygen bond, there is a, because anti-bonding molecular orbital are getting filled, the bond order will decrease. So you have to decide now, depending on what charge this metal is possessing, metal with the plus, metal with the minus, metal with the zero. Depending on what charge there is, that is how much the desperation there will be to accept the electrons. If somebody is a plus, that would immediately want a pair of electrons. If somebody is a minus, that would immediately want to give away the electrons. And as a result, what is going to happen? The carbon-oxygen bond order will decrease. Let's try to understand it. Let's take it forward. Please see, this is how the metal carbonyl chemistry looks like. Please check. The metal carbon pi bond is coming up. The carbon's lone pair present on the carbon in carbonyl has been donated to metal, and metal has donated to the anti-bonding molecular orbital, and this is what we are calling as metal carbonyl synergic bonding. Okay. Now here is question number 1 from the topic of metal carbonyl coming your way based on the simple knowledge of metal carbon bond. Which of the following does not have a metal carbon bond? This is a 5 here if in case you can't see it. Does not have a metal carbon bond. Correct. Okay, I hope you guys can see it. Metal carbonyl, this is very much a metal carbonyl. Metal carbonyl is very much a metal carbon bond. This is Grignard reagent, very much a metal carbon bond. This is also very much a metal carbon bond. This is a bonding between C2H5O minus and there is Al3 plus. So there are 3 such O minus with the C2H5. So this is where you don't have metal carbon bond. Okay, these kind of questions are simple. Now comes the question number 2. Which of the following has the longest carbon oxygen bond length? This is interesting question. Let's decide. CO has oxidation state of 0. First point to be noted, my lord. So iron will have an oxidation state of 2 minus. You can understand it has so much of the negative charge. Here it is CO minus. The minus charge is here 2 minus, way too much. Here nickel is 0, here manganese is +1. Okay. Has the longest carbon oxygen bond has been asked. So you can understand if the bond order decreases, the bond length increases. And I told you, wherever there are more number of electrons on the iron, there is more desperation. In simple terms, I'm telling you, more desperation to donate. And where will it donate? It will donate to anti-bonding molecular orbital of carbon monoxide. So if the electrons are going to anti-bonding molecular orbitals, you know that bond order decreases, bond length increases. So correct, the answer is option A. Okay. So keep that in mind. Fe2 minus is not as willing to accept a pair of electron. Already it has quite full of stomach. So it doesn't want to accept. So the one which is wanting to accept very fast, that is the one where the metal carbon bond is going to be the strongest here. Okay, not the minus. You know the kind of repulsions it will have. So we will go with the one which is positive. That means B will be the answer. Let's see if we have a question like that here or not. Let's check another question now. Question number 3 from the metal carbonyl chemistry. Okay, check this out. We have to find what is incorrect about homoleptic metal carbonyls. So there are just, let's say, nickel, and there are 4 carbonyls like this. Yeah. So metal carbonyls contain only sigma bond. This is one kind of a question. Metal carbonyl produces synergic effect. This is correct. This is absolutely correct. Metal carbon pi bond is formed by the back donation of electron from filled d orbital of metal to vacant p orbital of carbon. Sounds correct. Metal carbon sigma bond is formed by the donation of the lone pair of electrons from carbon monoxide. Sounds correct. So yes, it is not just the sigma bond but also a pi bond that gets formed. So this is one example. You can have another example of hex, six ligands around. So you know that there is not just sigma bond but also a pi bond. So D becomes the incorrect answer. We were not asked correct, we were asked incorrect. Okay, next question, question number 4 from this topic. In the isoelectronic series of metal carbonyls. Now, interestingly, if you see Mn plus, B minus, and what do we have next one? Cr. All of these have same number of electrons. The carbon-oxygen bond strength is expected to increase in the order. Carbon-oxygen bond strength. If there is a minus, then that will have more desperation to donate. Bond order decreases. So does the bond strength. So bond strength decreases in the minus one, and wherever there is a positive one, it would not want to donate as much. So bond order of CO, if we are talking about, is going to stay not as low as this one, right? There is some amount of back bonding, of course, that will happen, but this is way too much as compared to this. So bond strength is relatively high. So yes, B is absolutely right answer. Absolutely right answer. Are you clear with the metal carbonyl questions which are possible? Yeah.